Hello everyone, welcome back to the channel. In the previous video, we have discussed why robotics is important. Now, in this video, I am going to show a complete roadmap to learn robotics from basic level to a advanced level. Here, if you are a school student or diploma student or a guy who doesn't know where to start robotics with, and this is the right place, and you will be getting a better clarity to learn where to start and how to start and how can we go further to grow in the career of the robotics. I will start from basic coding and will end at ROS2, an advanced robotic programming software. And at the end of every stage, I will be giving you a project so that it will be easy for you to learn and grow in the field. So come on, let's get started. So before that, I expect you guys to comment what you need for the next video and how is my video clarity and things and how I am explaining. Does this is good or this could help me to grow up for my communication skill as well as my knowledge with robotics too. So let's get started and get into the video. So the step one is basic programming in C. Before touching any robot, you must understand the basic programming logic. So for doing a small prototype of a robot, you need at least a basic programming knowledge to develop that logic too. At this stage, you don't need to become an expert programmer, but you need some basic knowledge. You at least need some how the program works and how the logic can be developed from one end. It doesn't mean a beginner need to get an optimized code at his first attempt. Maybe at trying, everyone could make an optimized code. Only by practice an optimized code can be done. So if you are starting with programming with C, so what are the things you may need to be studies? Variables, data types, else if conditions, loops and functions. So these are the basic things you need to know if you want to start your first project in robotics. So then why we need to learn C? Because most embedded systems and microcontroller are based on C or C++ or maybe Python too, but Python is most not the common one, but C is the best way to start with, and it is the most probably widely used in all over the world if you are a starter. Here, your goal is not robotics yet. Your goal is to train your brain to think logically, to make a robot to walk around the streets. So, if you are getting through all the topics done and you need some projects to be done with C. So some of the simple project that you can done using C after learning the topic that I have mentioned before this, take the input from the user and make a decision like adding, subtracting or multiplication, division or some other formulas or something and print the output on the screen. So by this you can get how a logic can be developed using a programming language like C. So this could be helpful to grow, and by every single projects, maybe a task or a homework that you do could help you to complete this C practice as much as fast as you can. So probably this could take at least 15 to 30 days if you have some knowledge towards the C or any other programming language, or it can be achieved only by a regular basis practice. At least 2 hours a day, you can complete these things. I mean the topics which I have told before within a 15 days. Probably. Step 2 is entering into real robotics, that is Arduino. So once you understand basic programming language, you can next step into the world of Arduino. Arduino is a beginner friendly and perfect to enter robotics. Here you will learn what is microcontroller, digital input and output, how to write code and upload using C and into the Arduino microcontroller, how software control hardware. This is where your code starts creating real world components. So before you have been coding in your laptop and that would be running inside your laptop itself. But now you're getting your code to run something in real life, like a robot that is walking into the street. So project as these stages maybe a lot more project in this, but for the basic level, if you have one Arduino is mostly sufficiently enough to make it. So this is a LED blinking controller. You can see the video that is on my finger point. This is actually the project, and it will be a very simpler code to run. And for this you would be requiring only an Arduino. So if you're entering the Arduino and if you're starting with this project, it would be a very easy for you to start with Arduino. And let's getting up to the next level, the step 3 or the next step to go with would be sensors and actuators. First, your robot need to sense the environment. At this stage, you will learn IR sensor, ultrasonic sensor, LDR, temperature sensor, servo motors, and DC motors and stepper motors, and a lot. These are something that I have listed out if you are a beginner. So after this, you need to get explore about these. Maybe after once you completed these things that I have mentioned now, so after that you have to explore what are all the next sensors that are available in the market, what can be done, accelerometers, IMU, and a lot. So it is only by exploring by yourself. So by that you will be getting an understanding how sensor give input and how motors acts as an output. So this is where robotics become interesting. At this stage, you can make a obstacle avoidance car, a line following robot, or a lot more because you're getting into an IR sensor and ultrasonic. So it is easy for you to get integrating it with DC motors and make this project. These are the basic level projects. Maybe you guys could have an idea of making some other robots or some cars and lot more. So at this stage, you guys could evaluate that and you can do this. So for this, maybe compare with help of step 1 and step 2, it may take up to 20 days. Depends upon your capability. Maybe it could be done in 10 days too, if you are really enthusiastic towards it and you are really interested to work out on those things. So and you may be spending some cost, it would be around a very little. So maybe investing for studying is not a big deal for everyone, I think so. So getting into the step 4, electronics fundamental. So many beginners actually skip the electronics and later struggle to work with them because Arduino is an electronic device and sensors and others. If you guys are really getting into robotics, you need to get to know about some electronic fundamental like voltage, current, resistor, ohms, pull ups and pull downs and step up, step down, motor driver, power supply basics. And this knowledge helps you to avoid burning of components like Arduino. You may get oversupply to Arduino and burned out a lot more times if you are a beginner. So that actually happens a lot more time to me. And design stabling robot and troubleshooting problems easier. And some sensors may work with a lot more power, but we would be expecting things to work only with Arduino. So we need some external battery supplies to be working with those. So for that you need some electronic fundamental to work on those. Getting up to the next step, step 5. If you are getting with your C and C++ and Arduino and actuator sensors, you may next get into the PCB design. If you are really interested, you can, but it is actually a skippable place. So once you have completed the basic circuits, you can design your own circuit with the PCBs. So here what you will be learning, once your circuits work with breadboard, you can next step is to PCB design. So here what you will need to be learn is schematic design, component selection, PCB layout, signal and power routing. This makes your project professional looks, because while you are connecting using the breadboard, there will be a lot more meshing wires in it. But when you have a PCB, you will be using a limited wires and your project would be looking compact and treat for your eyes to look at. So making a PCB and learning with it is actually a good one. So the project for this stage is to make a simple basic motor controller PCB. This is a big upgrade for your messy wires. So your messy wires could be neglected and your project look aesthetic. And this would be taking at least a month for this to complete it, or maybe a 2 months if you have a fundamental your electronics are strong. Once you have, so then only after you can start working with the PCBs. Rather after if you want to learn PCB, or you can, or just skip it off, and next is you can go with Python programming. So comparing to the embedded C, you would be getting into a next level of programming language, that is the Python. It's usually heavily used in automations, robotics, ROS, and AI. At this stage, you will be learn Python basic code, looping, functions, file handling, serial communication, UART, maybe a lot more. Comparing to C, Python is easiest and a powerful one for the AI. Making your projects to start with working with AI, you definitely need to learn with Python. So here you need to control your motor and Arduino using Python with serial communication. That would be the best project that suits you when once you have completed learning Python. So then next coming is Raspberry Pi. So everyone have heard of it. Raspberry Pi is a mini computer actually. Comparing to Arduino, it is the most powerful one, and it is an expensive one to work with. So if you are definitely confident about Arduino, you can go with Raspberry Pi. And if you have stopped blowing up your Arduino, you can start with Raspberry Pi, because Raspberry Pis are actually costly. So you should not be eventually burning it. So you must be strong with Arduino and electronics. So after that you can move on to Raspberry Pi. So while coming to the Raspberry Pi, it is a mini computer. So here what you will need to be learn is Linux basics, GPIO control, camera interface, and running programs with Python. So if you want to integrate if you want to integrate your cameras or any AI with your robot, you definitely need a mini computer like Raspberry Pi. So Raspberry Pi is one of the best mini computers, but maybe in the market there are available. If you are a beginner, you can start with Raspberry Pi, or if you are making some big projects, so Jetson Nano and a lot more, or going STM boards too are available. So at this stage, you have learned Python as well as Raspberry Pi. You can make a very good project with camera based robot or Wi-Fi controlled robot. But what I would be recommend is you can make a camera based ball tracking robot at this stage. So you are very good with Python as well as Raspberry Pi. You can integrate them and have a ball tracking robot. That would be really fun for you to play with. And the next step it is, if you have done with these things, congratulations, you have already caused half the way of your dream to become a robotics engineer. So the next step it would be a 3D design and Fusion 360 model, or using SolidWorks or Creo, probably anything, or Blender or anything. So in all the steps you have done a robot using a simple breadboard and then refining it with a PCB, and you are done with a simple car with a cardboard box or something, and now you are getting into a 3D design means you definitely need ethics. So getting into it now, when you are starting with Fusion or SolidWorks or any other CAD softwares, at this stage you need to learn about 3D sketchings, part designs, assemblies, motor mounts and brackets, and design for fabrication, and how the thing can be fabricated. You need to develop, and that it is possible to it is possible to assemble your robot with these things. So everything must be calculated with your CAD while you are modeling your CAD. So what is the use of this is, you may, when coming without any idea you are doing something, you may have a lot more errors, and your expense would be making a loss of it. So by this you can design your things, design your 3D model on this, and you can then start making it, so the errors can be reduced, and you could be having a definite path, so where you are going to and what your end goal is. So at this stage, you can make your completely own robot body with CAD and assemble it as real life. And you need to check whether it is possible to assemble it through the CAD. And once if every errors and no other problem is with your CAD model, you can start making your design. So it would be a 3D printed or metal or any other things that depends on your expense sheets. So next is the advanced programming software coming into the ROS. So finally, ROS is actually not the final stage, but it is an advanced level. So after that, you may be learning reinforcements and Isaac and a lot more ISM scheme and a lot more. So it is actually just a path. So step 9 is ROS2, an advanced programming software. So ROS2 is actually one of the advanced programming. You have entered into the advanced level, but there are a lot more things you need to after ROS2 too. But ROS2 is most commonly used in most of the companies. So while coming to ROS2 is used in autonomous robots, industrial robots, and research and self-training autonomous robots. So what you need to learn with ROS2 is notes, topics, publishers, subscribers, robot simulation, navigation, gazebo, all this, controls, how to control ROS2 controls, nav stock, and a lot more comes. I don't want to mess up with. You can start with notes, topics, and publisher and subscriber, and later with gazebo and Orvis. And once you have completed with that, you can explore digging with your knowledge. So here what we are moving forward with, you can now build a professional robot. So while you're coming to ROS2, you can build a professional robot where you're moving from hobby robotics to your professional robotics career. So at this stage, you can make a project of differential drive robot using ROS with simulating. So while coming to ROS, you don't need to actually make a real one at every time. You can first start simulating with your gazebo workspace or a simulation workspace similarly. So you can make it in there and test the data that you get from it through all this. And once you have completed and once your programming status has been okay, you can start working with the real hardware. So that final message is, you don't need to learn everything at once. Robotics is a journey. Each steps build on the previous ones. If you follow this roadmap step by step and build projects at every stage, you will become confident in robotics. On this channel, I will follow this exact roadmap, starting from basics and slow moving to advanced robotics and ROS2. If this robot was really helpful, just make a comment and what video would you like to make next. So thank you for watching. I will see you in the next video. Tada, bye bye.